So for finding out the angle AOB, would you need OA and and AB?
And we have both of those. A to O to B.
Would that become minus A to O? Because O to A is positive.
Yeah. So you're trying to find. I see what you're saying. So you need this angle.
Yeah.
Let me see. B, C to B is 10i plus 10i plus 7j. I have a hunch about something. Let me see. This one is 5 right, 4 up. So its gradient is 4 over 5. No. I was hoping this would be a 90-degree angle, but it isn't. There's a noodle scratcher. A, O, B. We have two sides. I'm not sure. Let's see. Oh, we could find the magnitude of them for the length. Oh, I don't have a method. Let's see. If that was tan, that would be opposite over adjacent. Oh, hold on. What is OB as a vector?
OB?
Yeah.
Is that just... Well, J would be 0.
Yeah.
And I would be 12.
Yeah, so that's 12i. So we know the length of this bit will just be 12.
Yeah.
How could you get the length of OA?
Pythagoras.
Yeah.
Okay. So C squared minus, is it B squared?
It would just be a squared plus b squared.
Okay.
It's a diagonal line.
So that'd just be square root of 421.
Okay, and then same thing, AB.
Okay. So it'd be square root 7 squared plus 4 squared. Minus 4 squared, sorry.
And what do you get?
You get square root 33.
The minus 4 needs to be in a bracket, or you can just make it.
Oh, alright.
So
Okay. I got square root 65 now.
Okay, and so how can we use those two? And the third side is 12 to get that angle.
Okay. Wait, so we've got. Do we have the bottom, like the hypotenuse is 12i, but do we need it as like a full number?
It's not a hypotenuse, I don't think.
Okay. So we have square root of 41, square root of 65. Could you use TOA?
No, not a right angle triangle.
Oh, so would it be tan then? Inverse tan.
No, not a right angle triangle. So how do you find the length, sorry, the size of an angle in a scalene triangle when you know the three sides? Any idea how to do that?
No.
That would be cosine rule.
Okay. So opposite, no, adjacent and hypotenuse.
No, it's not a right angle triangle. Cosine rule. So back over.
Oh, c squared equals a squared. Should be c squared is 12 squared equals square root of 41 squared. How do I do it?
What is C?
Is c 12? Wait, no. Wait, what it? Is c 12 squared?
C, side C has to be opposite the angle C.
Oh, so it's 65 squared.
Yeah, root 65 squared.
Root 65, yeah.
Go on.
Wait, isn't it minus 2ab? Or is it bc?
You're right. Sorry, I'm just using the other form. AB.
And cos theta at the end. How come you have to put brackets around this root 65?
Because otherwise it would be the square root of 65 squared. Not.
I got 38.659.
Same. Let's see, and there's no shenanigans. That's probably what it is. Let me just see this thing. I don't see a quicker way of doing it.
Yeah.
So 38.7 to one decimal place. Yep. Because it's not, there's no SOHCAHTOA, there's no nothing. Okay. The angle BOC. How would you do that?
So could you need to use Pythagoras to work out the line on the left, the side of the left?
Not a right angled triangle.
Oh, wait. Oh, first could you just do... Wait. Could you do square root 10 squared plus 7 squared first?
Not a right angled triangle.
But how come we did it for the top then?
Oh,
We did square root 10 squared plus... Well, square root 7 squared minus 4.
which did you do? 10 and 7?
Yeah, I did 10 and 7.
Yeah, that'll work.
Which gives you square root 149 for that side.
9. Okay. We know OB is 12.
Okay. We can't use the cosine rule, can we?
Why not?
We don't have the left side.
So get the left side.
But you can't use Pythagoras.
In the previous one, how did we get the OB?
We just put the two together and added them.
Yep. So OB, let's see. So OB, not OB, OC will be the same as O to B plus B to C.
To be... Oh, right, okay. So it'd be 12... So would it be 12i
Mm-hmm.
plus 10i plus 7j,
Mm-hmm.
which would give you 22i plus 7j.
Yeah.
And then you do... It would be square root 22 squared plus 7 squared.
Yeah.
Which gives you square root of 533.
That's it.
Then we use the cosine rule,
Yeah.
which is c squared equals a squared plus b squared minus 2ab cos c.
Yeah.
So it'd be square root 149 equals
Don't forget squared.
squared, yeah. Square root 533 squared plus square root, no, 12 squared
Mm-hmm.
minus 2 multiplied by square root 533
Mm-hmm.
multiplied by 12 cos theta, cos c.
Yeah.
And then we can
And
put that.
yeah. And do you know what the square root of 149 squared is?
Just 149.
Yeah. So that might make it a bit easier.
Okay. I got 17.7 degrees.
That's it. And then part C, the angle AOC.
Okay. Just add the two answers you got for the first and second one.
Yep. And our first one was 38.660.
I got 56.36 or 56.4.
Okay. And so, let me just check. Answer plus 8.66. So I'm getting 56.3. Why is that?
I rounded the answer for the first one to 0.7, not 0.6.
So don't round it then. You can round the answer, but the working out, just see how I used like answer.
Yeah.
And so yeah, you could use 5 sig fig 17.650 plus 38.660, and then it would round properly to 3 sig fig.
Yeah.
56.3 degrees, and then this one was 17.650 degrees. 74.1. Why is that? It's because the other one's minus, that's why. It's going against the arrow. I didn't notice.
Oh.
So that's 12i minus 10i. So that would be minus 2 instead of 22. So square root of 2 squared plus 7 squared. That's root 53. Okay, so root 53. Oh, I'm sure it's fine. That should just be root 53.
Yeah.
Instead of... Hang on. No. Instead of root 533, it's root 53. It's just a coincidence, I'm sure. It's a shame. If I still had it in my calculator, I could mess around with it. Alright. Okay. Any questions there?
Nope.
Alright, I'm not doing the whole thing again. Let's see. So this looks very similar.
Yeah.
I don't want to do any more of this stuff. What is this? Maybe I'll put this before the previous one. Find the size of this angle Q to P to R. Let's see. So P to Q. Yeah, you would just find Pythagoras for that. P to R. You would find Pythagoras for that. What would be the next step?
You'd need to add the two together.
What, to get Q to R, is it?
Yeah, to get Q to R.
So, let me just see. So P to Q. Okay, so what is Q to R?
4i plus...
No. Q to R. You made the same mistake.
Oh, so it needs to be minus 4i minus j. Is that right?
Yeah.
And then add 6i minus 8i. J.
Yeah. And then that should work. So that would be 2i minus 9j, and then you would go from there.
Yeah.
Oh, what's this insanity? So we've been using cosine rule. The angle, say split it up into two parts. Ooh, I'm gonna have to look at that later. Okay. Right, this is worth doing. Oops. Okay, how about this one?
Okay. So what does it mean by magnitude? Does that mean the direction it's going in?
Magnitude on a vector diagram is represented by length. It's like size. So if this was, the force of someone's punch or something,
Yeah.
the longer the line, the stronger it was.
So the line's 6.5.
Yep. So this line, it is 6.5 long. It's also the vector A. It's also pi plus qj.
So when it says it makes an angle theta with the positive x-axis, is that bottom left?
Yeah.
And would you do inverse cos minus 5 over 12 to get that angle?
You could.
Okay. Which gives me 114.624.
Okay. We want possible values of P and Q.
Okay. Is P the bottom and Q the right? Because
Yeah.
P's going across and Q's going up.
Yeah.
So could you use saw?
All right.
Okay. So S equals over H. So it'd be 114 point. Do you need the angle of theta, cos theta?
Yep.
Like you need to inverse cos minus 5 over 2.
I think it'll work.
So in saw, what would I put in? 114.624, or do I put in like?
So sine, 114.62.
Okay. Cool. And then it'd be Q. Is the opposite always opposite the angle, right?
Yeah, that's what they mean. The side that's opposite the angle.
So it'd be 114.624 equals Q over 6.5.
Yeah.
And then you can multiply by 6.5 on both sides.
Yep.
Which gives you 6.5 sine 144.624 equals Q.
Yeah.
And then you put that into the calculator. Which gives 5.9.
So I think it's supposed to be 6. So it's the sine of arc cos of minus 5 over 12.
Yeah.
Nope. That's 5.9. That's not. I thought it might be 5.999 something. Okay, 5.90889.
Okay.
889. Let's see. There is something to this though. Cos is negative.
Cos is negative. Oh yeah, it is.
And so, what do we do about that?
Do we need to make the answer we got negative?
And so where is cos negative?
In the bottom right.
That's where cos is positive. This is positive. Shows
Oh, so it's on the left then.
Yeah, so it's in these two. So it's in one of these two. We don't know which one. If it's in the top left, what would be our answer for this? Or how would it be different?
5.90889.
And if it was in bottom left?
Would it be minus 5.90889?
Yeah, so it's plus or minus that.
Yeah.
So that's Q. How about P?
Okay. So I could use K.
Yep.
So it'd be cos 114.1624 equals adjacent, which is P over 6.5.
So basically cos theta is the adjacent, like P, over 6.5. And we also know that cos theta is minus 5 over 12.
Yeah. So we could use sine rule?
You could just solve it. So it's basically literally just P over 6.5 equals minus 5 over 12, because they're both equal to cos theta.
Okay.
You can do it manually if you're lazy.
I got minus 2.7.
Minus 2.71, let's say.
Okay.
Okay. And it looks like it's an exact fraction. Hold on. Yeah, there we go. Minus 65 over 24. So there's something that I don't like about this. They didn't give us... they didn't say an exact value, but I really think they should have.
Yeah.
So the P answer I'm a lot more confident with, because that was like they give us cos, P is cos, you know, like we can be very confident that P is minus 65 over 24. Like cos is negative, we know it's negative, they told us it's negative, they gave us cos. Yeah. The Q one, what if we squared both sides? Cos squared theta. And in fact, that's what I should have done. Hang on. I want to go back to this sine one. Sine this one. Answer equals... Okay. Yeah, what if we squared both sides? So what is cos squared theta equal to?
Minus 5 over 12 squared.
Yep. And go on, what is that?
Okay. Minus 25 over 144.
You never use brackets. What's what's a minus times a minus?
Positive.
Yeah.
Yes, it's 25 over 144.
Okay, that's cos squared theta. How do you swap between cos squared theta and sine squared theta? We need to become something to do with sine.
You need to make cos squared sine. It would be 1 minus sine.
Well done. So that's 1 minus sine squared theta.
Yeah.
And now solve that for sine.
Could you plus 1 on both sides?
It's already plus 1.
Okay.
You could minus 1. If you wanted.
Oh yeah, it'd be minus 1. So it'd be minus sine squared theta equals 25 over 144 minus 1.
That's it.
And then would you do square root on both sides?
Yep.
Okay. Which is 5 over 12. So minus sine theta equals 5 over 12 minus 1.
Hold on. That can't be right. Did you do 25 over 144 minus 1?
No.
You
We put minus 1 at the end. Okay. Square root. It says math error. Do you need to minus it first?
So they're both minus. Minus sine squared theta equals minus 119
Okay.
over 144.
And then you square root that, which it won't let me square root it because it's negative.
So make it positive. This is what minus sine squared theta is equal to. You could times both sides by minus 1 if you want to think about it that way.
Okay, so that gives you sine theta, or sine squared theta still, equals the answer 119 over 144.
Yeah.
And then you square root both sides.
Yeah.
Which is square root 119 over 12.
That's it. And
And then you do inverse sine.
slow down. Over 12. The value of Q is sine theta, isn't it? Sorry, it's 6.5 sine theta. Q is 6.5 sine theta. Sine theta is this value. And in fact, we earlier said that it was plus or minus. Yeah, don't forget that plus or minus.
Yeah, so there's two answers.
What are the two answers?
One of them, well, we still haven't inverse signed them, but one of them would be minus and one of them would be positive.
Yes, but no. Okay. Sine theta is Q over 6.5, yeah?
Yeah.
And so Q is 6.5 times sine theta?
So would you put 6.5 at the start of sine?
Yeah. We would times both sides by 6.5.
Okay. So for the positive, would you need to do positive and negative?
Yeah.
Okay.
And you can put it in the calculator. Like answer times 6.5.
Okay.
It's gonna look like that.
I got for the positive 13 and then square root over 119 over 24. And that's plus or minus, and one of them would be minus.
13 over 24, was it?
13 square root of 119 over 24.
That's it. Yeah, so plus or minus 13 root 119 over 24. Let me just see. Answer equals 5.99. So there we go. So the other one gave us an approximate answer, whereas this is an exact answer. And yeah. I think that this is what we need for this one. Let's see how crazy we were. -6 and plus or minus 2.5. What are they referring to? So P is minus 6. But I don't know what they're referring to. Let me just take one last look at this thing. So we have a vector A. So the reason why you can have plus or minus is because you have a vector A, and it could go like that.
Yeah.
But it could also go like that. It could also go like that. It could also go like that. Because it's like a peak. Well, and if we look at what they're saying, the answer is Q is plus or minus. So it could go up or it could go down.
Yeah.
And I think two of these will give you the same thing, which is why you end up with 3 possibilities. No, you end up with 2 possibilities. Let's see. The vector A is that has a magnitude of 6.5, and it makes an angle with the positive x-axis. Well, let me see. So if it has a magnitude of 6.5, then we know the square root of p squared plus q squared is 6.5. And then we also know that arctan of the angle. Well, let's see. We know cos theta. So that's the adjacent to right hypotenuse. I mean, we really don't know. 1 second. So this is similar. This is very similar. Okay, this is very similar. Let's try this one. See what's going on. Magnitude of 10 makes an angle theta. Thank you.
So the angle will be in the bottom left.
With the positive x-axis. I think I see it. I see it. Hold on. With the positive x-axis. So if I go back, with the positive x-axis, it could be like that, or it could be the other side. You know what I mean?
Yeah.
And so I think that's what's going on here. Okay. So we don't know what way it's going to go, but we'll just make it look like that for the moment.
Yeah.
Okay. How do we do this one?
Okay. Do we do inverse sine first to get theta? What theta is?
You haven't learned a thing. So that will get you a decimal answer.
Yeah.
Instead, to get an exact answer, you would like square it and go about it that way.
Yeah. So it can be plus or minus, right? Because it goes up and down.
Sine squared theta equals.
Sine squared theta equals. Three over 5 squared.
Yep.
Which is 9 over 25.
Mm-hmm.
And then we just want theta, right?
Yeah, well, we want cos theta.
Okay, so we make sine squared 1 minus cos squared theta
Yeah,
equals 9 over 25. And then we can minus 1 on both sides, it becomes minus cos squared theta equals 9 over 12 minus 1. 9 over 25, sorry.
and that'll give you minus 16 over 25.
Okay. Cos. And then you can multiply by minus 1 on both sides.
Yeah.
Which gives you cos squared theta equals 16 over 25.
Mm-hmm.
And then you can square root both sides.
Yep.
Which is 4 over 5. So cos theta equals 4 over 5.
There's one more possibility.
Plus or minus 4 over 5.
Yeah, because sine could be either the top right, where cos is plus, or top left, it's also positive, where it's negative. Yeah. So plus or minus 4 over 5. So if we go back to our original diagram, and we're just using that as a sketch, whatever. So P is the x direction. P is adjacent. And so P is 10 cos theta. And then Q is the other one. Q is 10 sine theta.
Okay.
And so, let's see. What is P? What is Q? Given that sine theta is 3 over 5 and cos theta is plus or minus 4 over 5.
Okay. So P is 10 cos plus or minus 4 over 5. Oh, it can be.
No. Theta isn't plus or minus 4 over 5. Cos theta is plus or minus 4 over 5. Start with the sine theta one. So what is Q?
Wouldn't it just be 10 sine?
10 sine theta? What is sine theta?
3 over 5. Oh, just 10 3 over 5.
Yeah, so it's not sine 3 over 5. Sine theta is 3 over 5.
Okay.
Yeah.
Which gives you 6. So Q is 6.
Okay, how about P?
Okay. P is 10 multiplied by minus or positive 4 over 5.
Yep.
Which is 8 or minus 8.
So Q is 6, P is plus or minus 8. Q is, they're saying that's plus or minus. Why is that? Let's see. Consider also the case where that's symmetry. Right, there's a bunch of malarkey, is there? I know why. It's because you have to do this whole sine theta equals sine 180 minus theta. And so that one could also have been plus or minus. Alright, so they're both plus or minus.
Okay.
Hey, cheetahs, man. Alright, we did alright. Okay, any questions with that one?
Nope.
I'm leaving that one behind forever. Okay, so that stuff, what do you give yourself?
Probably between a tick and a half.
So, tricky stuff. Man, took forever. Okay, position vectors. A position vector starts from the origin. So a position vector starts from 0, 0, and let's say if it was like 3 to the right and 4 up, then as a position vector it's 3, 4. Most vectors
Yeah.
are just anywhere. Like most vectors just like 3 to the right, 4 up, but just in general, whereas a position vector starts from the origin. Let's see, the position vector of A.
Okay. Would that just be 4,
Other way around.
5, 4?
A.
Oh wait, 4,
Other way around.
3, 4.
Yep. So that's position vector of A because it starts from the origin. Position vector of B.
11, 12.
11, 12. 11,
No,
12.
2, sorry.
11, 2. And then the vector AB.
Wouldn't that just be A minus B?
Let's see. Other way around.
B minus
Yep.
A.
Yeah, it's like minus A plus B or B minus A.
So that'd give you 8 minus 2.
And so that is 8 and minus 2.
Yeah.
And what that shows you is the position vector of AB is OB minus OA. I should have written OA because we just called them A and B. So A to B is equal to O to B, second letter, minus OA.
Yeah.
So you don't have to sketch. There we go. Stated INJ. It's fine. Okay. How about this one?
We don't know what J is for B though.
Don't need to.
Okay. So AB equals OB minus 5A minus 2J.
Yep. What is AB?
Oh, AB is a 3I plus 4J.
Yep.
And then do we just want OB on one side?
Yep.
So can we just minus OB on both sides?
It'd be easier to add OA on both sides.
Okay. So you'd add OA both sides, which gives you 8I add 6J equals OB.
Yep. And then how about B?
Is B 6J?
Magnitude of OB. 8 right, 2 up.
Oh. So it'd be 8 2.
Sorry?
Would it be 8 2?
Magnitude means length.
Oh, so it's squared and then square rooted?
Yep.
Okay. So it'd be square root 8 squared plus 2 squared, which gives you 2 square root 17.
Great, well done. And so for this one, with our position vectors, you have O to A, O to B, and then A to B is minus O to A plus O to B, or O to B minus O to A. And so in general, A to B is O to B minus O to A. So it's like from the origin to the second one, take away from the origin to the first. And we just used that for this one.
Yeah.
Magnitude is length 2 root 17. Okay, how about this?
Okay. So could you write out as 7i minus 6j?
Minus 7i minus 6j, yeah.
Yeah. So wouldn't it be AB equals OA minus OB?
Other way around.
OB minus OA.
Yeah. And actually we want the position vector of B, and so rearrange the formula.
So would you plus OA on both sides?
Yeah.
Which gives you OB plus AB equals OA plus AB equals OB.
Yeah. OA plus AB equals OB. Okay, get the position vector of B.
Okay. So would it become 7i plus 6j OA because you added it on both sides?
Yep. I don't think so actually, because it was minus minus. It was minus minus. Yeah, so if it's over there, it's just OA. OA is just minus 7, minus 6.
Okay. Which gives you minus 4, 5.
That's it. Minus 4, 5. And that's OB. Okay, try part B.
Okay. So when squaring a minus, is that in brackets? Would you put my brackets minus 4 and then squared?
Yeah, or just make it plus. 1 second, that'll be a second.
So I did square root brackets, open brackets minus 4 close brackets squared plus 5 squared, which is square root of 41.
Sorry, my toes messing around with a tin whistle or something.
It's fine. I got square root of 41.
Okay, root 41. Yeah, now we're doing it. Hang on, minus 4 or 5. We said minus 4 or 5.
Yep.
Aha. Alright. How about this?
So is that the equation y equals 2x minus 3?
Mm-hmm. So one important aspect of it, the gradient is 2.
Yeah.
Which is the same as 2 divided by 1. And that's change in y over change in x. So we know that, let's see, it has to be parallel to 2. And so the vector OP times by something gives you 2.
Okay.
Oh, we can find that angle, I suppose.
Okay. So I could use Ka. Oh no, wait, no. No.
It's like the reverse of this one. O to P.
So I could use Toa.
Yeah. So it'll be arctan 2, I believe. Opposite over J. Yep.
So it'd be inverse tan. Would it be inverse tan 2?
Yep.
Which is 63.434.
Alright.
435.
Let's see. So O to P. So we know P squared. Well, let's see. So arctan P over Q is the same as arctan 2. So we know P over Q equals 2. I think this will work. P over Q gives you 2.
Yeah.
We also know that P squared plus Q squared gives you 53. Because of Pythagoras. So let's say for this top one, what is P equal to in terms of Q? If you made P the subject.
Oh. P equals 2 over Q.
2 times Q.
2 times Q.
So P is 2Q. And so P squared is 2Q squared.
Okay.
And then you'd have to solve that, I believe.
So could you square root both sides?
Not yet. What is 2Q squared?
2 squared Q squared.
Yeah.
Or 4Q squared.
Yeah. So 4Q squared plus 1Q squared.
And then can you add to the 4Q squared plus another 4Q squared?
Yeah.
So that will become 5Q squared still.
Yeah, so 5Q squared is 53.
Then d divide by 5 on both sides.
Yep.
Which is 10.6.
Actually, that's 53 over 5.
And then you square root both sides.
Yeah.
Which is 3.256.
Plus or minus. So it's plus or minus root 53 over 5. How about p?
Okay.
P is 2q.
So we just do 2 times square root plus or minus square root 53 over 5.
Yep. So that's just plus or minus 2 root 53 over 5. Grand. All right. Any questions about that one?
Nope.
All right. How was that for you, Adam?
That was great.
And so, continue this stuff next time.
Yep.
How are you doing? Are you feeling all right?
Yeah, I'm doing good.
Hey, that's good. I'll tell you, man. I hope everyone's feeling good.
Yeah.
Let's see. And when's our next lesson again?
Next week.
I
think we did 4 next week, didn't we?
Yeah, I think I have it in my calendar, like starting Monday or something. Yeah. Any questions, me in general?
Nope.
All right. Well, have a happy Christmas, Adam. And
You too. Merry Christmas. Happy New Year.
Cheers. And talk to you next week.
You too.
All right. Take care. Goodbye.
Bye.
Bye.